So let's conclude the lecture and let's talk about our takeaways, or better said, you go ahead and define what are your takeaways and what you have learned, just as much as what's still not clear to you and where you need more clarification. And once you're done with that, let's move on to the final checkpoints and let's talk about our goals for this lecture and what we had in mind to teach you here specifically. So first of all, it should help you to understand what self-weight of a structure really is and how you can represent that by evenly distributed forces. So please make sure that that is clearly understood. Then you learned with the evenly distributed forces that you can actually lump a force into a single concentrated force, at least conceptually, so that you can apply this force at the center of the evenly distributed force for your calculations. So that should also be clear, and I think that was taught throughout this lecture. Then you definitely learned about the resistance that a fixed support really provides. So let's make sure that we understand the fixed support. And last lecture we called that restricted degrees of freedom. And we today use that to clarify that all three types of equilibrium are balanced at that one location, at the fixed support. That is something we definitely took away from this lecture. And that also helped us to study and learn how to solve support reactions, or three support reactions for cantilever beams. That was the only thing we discussed in this lecture, cantilever beams. And we did that for the distributed forces and the concentrated forces. So we can definitely check that off. But we also learned that the system can be much more complex if you have non-evenly distributed forces. So we are aware that this, of course, is all an idealization and that in real life it can be more complex. In fact, when it becomes more complex, you may end up with non-evenly distributed forces, but you learned that they can also be lumped up into a single concentrated force simply by finding the area under the curve and then find the location, so you understand where this concentrated force must be located. At least conceptually we talked about that. And last but not least, we talked about the concentrated moments and how they affect the equilibrium equations and what they do to a structure. So when you solve for support reactions, you know now how to deal specifically with concentrated moments. So we can check that off. And I believe those are enough and good goals for one lecture, so that we can now move on and talk about the homework assignments. For the upcoming homework, it is probably not a surprise to you that we're dealing with cantilever beams and cantilever beams only to apply our newly gained knowledge. But let's take a look at the individual problems and what you have to do here. So we're not trying to insult your intelligence here with the first problem. It probably looks too easy to you, but we want you to have an easy way in and give everybody the same chance to develop their knowledge. So very simple problem, support at A, a fixed support at A, and then only one concentrated force at the end of the beam. I don't think it gets any easier in this class. But again, we're not trying to insult your intelligence. We're just giving everybody a chance to perform from the ground up. All right, for the next problem, it becomes a little bit more interesting. Support as well on the left side, and we have now forces in two dimensions, in the X and in the Y direction. There's also a force here at the end of the cantilever beam. So this speaks for itself, I believe. Everything is given here, the angles and the forces and the distances. So I'm sure you can solve that as well. Then we have probably the easiest distributed force problem here waiting for you, where it's just a single distributed force on the entire length of this cantilever beam, with the support in this case on the right side. Let's move on to the next problem, where it really becomes interesting. And here you have to deal with all the different load cases, or some of the different load cases: distributed force, concentrated force, and a moment, all acting on a cantilever. And I believe I don't have to say much about this problem. I think all the information is contained within this lecture. Then we have a triangular distributed force here for the specific case where the heavy side is actually close to the support. And that also doesn't require much information because it was all explained throughout the lecture. Last but not least, we have a structure where the heavy side of the triangle is far away from the support. So here you have a triangle that doesn't act over the entire length. But I think how to solve this does not require a lot of explanation right now. All that information is contained within the lecture. I wish you good luck with that. In fact, I wish you good luck with the entire homework. And I will see you in the next lecture. Stay safe.